Karl Popper and Falsification, Part 2, Sophisticated Falsification. In Part 1, you've all learned the basic premise of initial falsification. Basically, in order for a hypothesis to be worthy of a scientist's consideration, it should be able to be falsified but never actually be falsified. In other words, there should be ample opportunities to falsify the theory, but the theory must stand up to each of those observations or experiments to survive. However, Popper eventually realized that although this falsification is valid in logic, it is rather limited and raises some problems, such as that some scientific theories seem to be irrational to it. For example, Mercury's perihelion was regarded as an anomaly of Newton's theory, yet other evidence for it was so strong that it was not generally regarded as a falsifier. So in light of this and other issues, Popper attempts to improve this naive falsification and make it more sophisticated by giving it a new set of rules and criteria. According to sophisticated falsificationism, a scientific theory, T1, is falsified if another theory, T2, comes along and satisfies three conditions. The new theory must have excess empirical content over T1, which basically means that it can predict novel facts that the original theory cannot explain. The new theory must also include all of the refuted content of T1, in other words, so it must be able to explain the exact same phenomena. And finally, some of the excess content of the new theory is confirmed by experiment or observation, which means that some of the content of the new theory must be partially supported by the content from the old theory. So these points enforce that excess and confirmed empirical content replaces experimental evidence to falsify a theory among a series of theories. A theory simply cannot be abandoned as falsified until a better one is found. Even if we find that there are experiments or observations that are contradictory with our theory, all of them are not enough to falsify or reject the theory. We must get a better one, and ultimately, this is how a theory grows or develops. So sophisticated falsification, therefore, is not a two-sided relation between a theory and experiments, but it's actually a multiple relation among rival theories and experiments. For example, what makes Einstein's theory of relativity better than Newton's theory? Well, according to a naive falsificationist, simply because one is falsified, whereas the other is not, would do it. But we all know that the real reason is that Einstein's relativity explains not only phenomena of Newton's theory, but also facts about electromagnetic waves which Newton cannot. This demonstrates how an older theory is replaced by a new one that explains the same stuff as well as something novel, which is progress. So how does science grow objectively? Well, sophisticated falsificationists think that science is composed of both bold conjectures and cautious conjectures. Scientists adopt different attitudes to falsification according to these different conjectures. The cautious conjectures have a lower degree of risk, so the falsification of them can provide us with more information, and generally speaking, bold conjectures have a high degree of risk. It shows that bold conjectures predict some novel facts which are inconsistent with our existing scientific theories. Now, Popper, he initially thought that, well, falsification is the way to go, so falsification of all the big ideas is what would improve the theories, but unfortunately that didn't get us anywhere. The falsification of a big, bold, or a good new idea is pretty much exactly what you would probably expect to happen because the idea is so big in the first place. Whereas if you confirm the idea, that would likely be more informative. So only the confirmation of bold conjectures and the falsification of cautious conjectures are helpful to the prediction of novel facts. Once a conjecture is confirmed to be part of a scientific theory, it's not bold anymore. It just becomes part of the background knowledge, but we can't actually throw it out and just disregard it. For example, the Copernican theory is bold and relative, or not a novel relative to Ptolemaic theory, but it's not actually relative to Kepler's theory. So sophisticated falsification has two main characters. Firstly, sophisticated falsificationists recognize the continuity of scientific knowledge and specify a series of theories rather than a particular theory as the basic research unit of science. By the replacement, they make falsifiability a comparative or a relative matter, since it is difficult for us to be sure what the degree of falsifiability of a particular theory is, but we can make sure which one is more falsifiable by comparing two theories. For example, in general, a theory with a higher degree of falsifiability will be capable of testing in a greater number of circumstances. So this is what makes it more strict than naive falsificationism at that point. Secondly, sophisticated falsificationists clarify the influence of auxiliary hypotheses on theories. So to quote Popper himself, saving a theory with the help of auxiliary hypotheses which satisfy certain well-defined conditions represents scientific progress, but saving a theory with the help of auxiliary hypotheses which do not represents degeneration. So linguistic adjustments and hypotheses which fail to be tested in any way are regarded as ad hoc and removed from the convention of auxiliary hypothesis. So I know what you guys are all saying. What in the world do I mean by ad hoc? Well, ad hoc is basically an addition to the hypothesis that you can't test. It's just there in order to protect your hypothesis. So a good example of this is an argument actually between Galileo and an Aristotelian adversary, where Galileo was claiming that the moon had craters and it wasn't a perfectly spherical shape, just as Aristotle had said. Whereas the other guy, he came out and he claimed that, no, Galileo, buddy, you're wrong, because each of the craters are actually filled with an invisible fluid, and that invisible fluid makes it perfectly spherical. So Galileo laughed, and he looked back and said at him, how can you test that that's there? And he said, okay, well, there's also invisible fluid there that makes mountains, so my invisible fluid mountains also make it not perfectly spherical, so I'm still right and you're wrong. So in other words, in order for science to progress theoretically, rather than be trumped by random untestable additions to hypotheses that you can't actually falsify, it has to have new relative content that can be tested. So this is all great, but you guys are probably saying, okay, I understand all this, but how exactly is sophisticated falsification an advancement of the original falsification? Just give me the apples and oranges contrast, please. So basically, falsification deals with individual theories, whereas sophisticated falsification deals with series of theories. Moreover, their methods to deal with a falsified theory are different. Naive falsificationism rejects it, whereas sophisticated falsification replaces it by a better one. The better one has all the unrefuted content of the previous theory, which makes sophisticated falsificationism more tolerant. And finally, their understandings about the components of science are different. According to a naive falsificationist, science consists of conjectures and scientists' attempts to falsify them, whereas according to sophisticated falsificationism, science consists of cautious conjectures, but also bold conjectures, and scientists attempt to falsify the cautious ones and then to confirm the bold ones. So in summary, falsificationism has developed in different forms, but it's still somewhat insufficient to describe science in general or to solve the science versus non-science problem. It suffers from a series of logical and philosophical difficulties, which should perhaps give us pause if hoping to find a single answer to what makes good science and what does not. And some of these weaknesses and limitations will be outlined in the next presentation.